Good afternoon and welcome. Thank you for joining us for this month's webinar. We're going to be talking about authentication. We're going to be covering a lot of ground. Kind of accidentally named this thing from NTLM to Passkeys, and in doing so encompassed both protocols and methods. So we're going to try to do a lot of stuff in a fairly short amount of time. So in order to do that, we're going to jump right in and we're going to sort of ground this by talking about, first of all, what is authentication, right? All up, what is authentication? And this is from a Microsoft website, and I think they maybe slightly too narrowly define it as authentication is a process that companies use to confirm that only the right people, services, and apps with the right permissions, and pardon me, I have a second screen over here, so I'm reading it over here, have access to or get to organizational resources. So I think that is a great description of what authentication is, but I think it's actually too narrow because people have been authenticating and providing identity to systems and to organizations and to governments for thousands of years. And we'll cover that a little bit as just a way to understand sort of what it is that we're extending by moving into modern day scenarios where we have multiple different authentication systems that exist around us all the time. We authenticate over and over and over again every single day, right? It's not just one size fits all. We don't just log into Windows and by virtue of being in Windows have access to everything. There are so many different authentication scenarios happening behind the scenes, under the blankets, however you want to define it. It would be exhausting and exhaustive to go through a million different diagrams and scenarios that explain everything in explicit detail. So let's talk about why we're talking about authentication today. We are talking about authentication today because Microsoft is removing a major authentication protocol from Windows. They announced last year, after several years of developing the support for Kerberos to authenticate to Azure files, that they are now moving forward with plans to deprecate NTLM from Windows. And this has significant implications because NTLM does a lot of heavy lifting even in a very modern world of Windows 11 and Active Directory 2022 and all kinds of stuff like that. There's still a lot of local fallback and authentic and cached, if you will, credential usage coming through NTLM in Windows today. So let's talk about why we authenticate, how we authenticate, what are our major scenarios, and what are our major components of an authentication system. So we need to start, and again, this is not going to be exhaustive. I could boil the ocean and we still wouldn't come anywhere close to covering all that authentication is and can be. So at a root level, we need a protocol, we need a method, and we need parties involved, right? Our protocol is going to define what values are shared and how. How are we protecting those values? Oh, sorry, I'm getting ahead of myself. Sorry. Is there flexibility in this system? Are we stuck using just a credential pair? Are there hashes involved? Are we salting hashes? Are we using encryption ciphers, right? There's a lot of complexity that goes into defining the protocol itself. And sometimes defining the protocol will actually impact the methods or even the participants that are involved too. So when we move into the methods, we're defining, again, what factors are supported or necessary. Some are very limited and will only, again, support that original key pair of a username and a password. And some will be very open and flexible. And then we need to move into the participants discussion. Many authentication protocols only authenticate the client. They are you walking up to somebody and saying, "Hi, I'm Joe, let me in," without really necessarily knowing who's on the other side of that conversation. So as authentication has evolved over time, so too have the components that are a part of it. And so too have the purposes behind it. A lot of what we're going to be talking about today will relate principally to logging into Windows. And you'll see I've covered a lot of ground from 1993 to where we are today, both in terms of logging into Windows, but we'll also talk about application authentication and website authentication, and even a little bit about service account, although I don't really dig into it deeply, and we're not even touching on remote access, right? So there's a lot of different types of authentications that serve a lot of different types of purposes. So we're going to try to keep our focus today around Windows, because that's the part that's going away. And then we'll talk a little bit about cloud authentication, because that's where a lot of our technologies are evolving and improvements are coming. So It's wild that we actually haven't talked about authentication much over the years, because 2 years ago we produced a webinar, and it's actually out on our YouTube channel right now, that talks about conditional access as being a post-authentication behavior, and that is still very much the case today. Conditional access looks at what you have brought to the table, both in terms of your authentication, the protocol, the risk of your identity, all this stuff, and layering it into what's the operating system you're coming from, the network location, all of that stuff. But it can only happen once you've already finished the authentication process itself. And last year I got an opportunity to present at RVASEC, at a public conference here in Richmond, around I Heart My Password, right? And the focus of that conversation was really around the evolution of identity itself, and what we as IT have sort of inflicted upon our users over time, but it really still didn't look carefully at authentication. What it did though was it dug into what is identity and how has that evolved over time. And very briefly, because the video is still out on the YouTubes and you can go and watch it today, what we looked at was sort of how we've evolved the usage of identity over time, not just in computer systems, but in the world itself, right? Going back thousands of years, we've had the ability to present details of our identity to organizations, to governing bodies, to other governing bodies, to prove that we are who we say we are, right? We can go all the way back thousands of years to ancient civilizations with jewelries and tattoos. We don't even start to get into census data and things like birth certificates and records of citizenship records until we get to the Roman era. Then we start to move like 1,000-ish years forward. We get passports. Victorian era introduces photographs and fingerprints. We're not actually looking at digitization of data until around the 1970s. And incidentally, if we start looking at the application of some of this identity, there's the very first recorded use of passwords themselves dates back to the 11th century BCE with the concept of what was called a shibboleth password. And that relied on how one group of people was able to pronounce the word shibboleth, and another group of people simply didn't have the sh phoneme in their language, and so they couldn't pronounce it. And this was used to identify if people were from the right group of people, right, to allow them to cross a river. We move forward into the use of things like keys and locks, right? And so still at a very simple level, we are taking a client who wants to authenticate or get access into a server. So that's somebody wants to cross the river or they want to get access into the box, they stick a key in. And for a long time, that's good enough, right? We move forward pretty far into the use of spies and tattoos on the sides of heads that was hidden under hair in the Roman era. We move really, really far forward into things like Enigma machines and code talkers in World War II, because now we need to introduce this concept of there's something else involved in defining what is the access method. And this is the first time where we start to have a third party involved, right? It's not just a client that wants to gain access to a secret. There's now something else that controls the rotation. There's something else that defines how do I know that this data is up to date. And yeah, you could actually say that the Roman watchword with daily rotations sort of meets that, but that was very difficult to disseminate across a large empire with pieces of wood that had to be burned daily. It is not until 1974 that we get our first password hashing in Unix. This is where we first start to recognize that there are enough people needing to use a single computer, and that maybe we ought to keep them isolated from each other and not just have them type a username and a password in and get them direct access into it. We're starting to recognize that passwords themselves are targets and that they must be protected. And then, wildly, and this date will become important in a minute too, in 1993, we have the release of Kerberos 5. Now, we are still technically using Kerberos 5 today. And I have in the past jokingly attacked that age. At 31 years old, Kerberos 5 now benefits from all the insurance benefits of being a fully realized adult. It's no longer paying, youth taxes on its automotive insurance and all that kind of silly stuff. But the reality is, they got it pretty good, right? And there have been some minor revisions to how Kerberos works. But let's talk a little bit about what authentication protocols have been supported in Windows over that same period of time. Because this chart recognizes the ways that we've been able to log into Windows since 1993. Okay, so we go all the way back to PAP, which was the Password Authentication Protocol. And you'll notice on this chart that we have the name of the protocol, we have whether or not it's supported encryption, because remember when we talk about our major components of an authentication protocol, that decision is going to have, it's going to cause ramifications down the road, right? Is it going to support certain different types of factors? Well, if we choose PAP, up here at the very top, we are not going to be able to encrypt this communication in any way, right? In PAP, we are simply delivering a username and a password to be evaluated against something in a stored database somewhere in plain text to grant access to something. That is very old. We don't do that anymore in Windows. There are still some web services where that is still the way that they are developed. I highly encourage, if you're developing a web service, please don't do this. These tend to get taken down pretty publicly, and sometimes with millions of records in them, and it's still kind of alarming today to see this being done. Anyway, we have the name of the protocol. We have whether or not encryption is supported as part of the authentication mechanism. We have whether or not the password is hashed, which means scrambled up into some predictable manner, and whether or not that hash is salted. Now, in most authentication scenarios that we have experienced within the last, let's say, 25 years, we are going to hash passwords. We are not going to directly store raw passwords in the password database. What we're going to do is we're going to store the hash, right? We're going to scramble it up in some sort of mathematically predictable way. We're going to stick the hash somewhere. And then when the user types in their password into their credential verifier, they hit enter. That will hash that value. And the comparison will between the client and the server value will be evaluated to see, is this the same hash value? Okay, very simple. Hashing is a critical element of any authentication protocol. Again, we're ruling out PAP right off the bat. Then we need to layer in, do we salt that? As part of the challenge between the client and the server, is the server also throwing back some similarly randomized numerical value that's being used to change that hash a little bit, such that the verifying version of it can only be decrypted by the server itself, or compared to against the server itself. So we're tweaking the hash a little bit to make it unique to that conversation. And again, PAP and CHAP and MS-CHAP, which was Microsoft's first VPN authentication scenario, and all the way down to LM and NTLM, do not salt those passwords. You type in the hash is verified against hash in the database, the NTDTS database, or whatever it's called, and user simply allowed in, okay? And then we add in, is the authentication supporting mutual authentication? Remember I said, I'm Joe, let me in. You're screaming at a blank wall. You really hope the guy on the other side is a good guy and not a bad guy. Without mutual authentication, it's very difficult to tell, are you actually authenticating to the resource that you want, and is anybody sitting in the middle listening to that conversation? Do they have the ability to take your credentials and just go where they want? And we'll cover that a little bit later, because NTLM, crucially, doesn't really do that, and Kerberos does. And then we can also layer in, like, what is the authentication method here? Again, because that is a predetermined calculation, or determine, it's a predetermined set of values if you're using some of the legacy protocols, right? Later protocols may allow you to use different authentication methods, and we'll cover that in a little bit too. And then there's going to be different use cases that are going to be defined by these. So we've covered a lot of different types of authentication, but you'll notice in the encryption column, these values are kind of wildly disparate. And so it's worth taking a moment to talk about those values themselves a little bit too, because again, PAP has nothing, and sometimes nothing is a really terrible idea, but sometimes the options that we get are not much better, right? Because because authentication itself has changed over time, so too have the other technologies that it calls upon. The encryption ciphers have also changed dramatically over the last 30 years. And we would generally not want to rely on DES encryption, right? It's kind of a known open problem in the encryption cipher world, that it is susceptible to brute force and linear and differential cryptanalysis, right? So we look at one of the challenges that we get into with LM and NTLM, and the reason why we're going to come back to this, is that you'll notice that LM breaks passwords into 7-character chunks, pads each chunk with zeros to make it a full 7 bytes long if the password length is not a multiple of 7, and then this hash is used for authentication. So anytime you encounter a password that's 8 characters or more, you get multiple hashes. And you're going to get as many hashes as there are multiples of 7 or 7 character value, seven character value places, excuse me, in your password. Now, that sounds terrible, and it is, because that means that, you know, any 7 characters is going to be its own separate hash, and you can just attack little 7-character hashes. This actually carries through as an encryption cipher in NTLM. And that's a really important thing, and that's why in Active Directory, all the recommended password requirements say 8-character passwords or more, so that at a bare minimum, you increase the number of password hashes by 100% if you simply enforce an 8-character password. That's no longer an issue in later encryption ciphers, but it's worth knowing that LM hash as an encryption mechanism for NTLM is probably not a super great idea, right? So we also get into challenges with some of the other protocols that are out here too. You will note, if you looked at the previous slide, that Kerberos supports RC4 as an encryption cipher. RC4 is vulnerable to several attacks. And it's important to know, if you're going to use some of these authentication protocols or some of the encryption ciphers, that you're using them in the right ways and the right times. Critically, TLS 1.0, which I didn't even cover because it's a web authentication protocol, is susceptible to RC4 attacks. So we don't use it, and TLS version 1.0 is simply obsolete. We don't use it at all anymore, and it's because of the RC4 support. There have been instances where admins have attempted to go in and remove RC4 from Active Directory, and sometimes run into really challenging results. There have also been scenarios where admins have attempted to remove NTLM support because it is susceptible to challenges like attacks on the LM hash values. But it turns out NTLM actually does some really good work for us. So I mentioned early on that NTLM does a lot of local authentication lifting for us, right? So NTLM does not require a local connection to a domain controller. And this is where we're going to start to see some differentiation between Kerberos and NTLM. And I'll draw some diagrams here, and we'll talk about that a little bit more directly. But NTLM is always the fallback authentication protocol wherever Kerberos is not supported. And it turns out there's actually a fair number of scenarios where Kerberos isn't directly supported. And one of the most interesting ones that I've stumbled across is that the first domain controller in a domain, when it is promoted, the administrator on an account on that machine becomes the first domain admin. And because you have to have a domain controller to authenticate your users, and the first DC wasn't a domain controller when it became one, it was a local account. And you see in bullet point 2 here, it's the only protocol supported when using local accounts. That first domain admin account actually cannot use Kerberos. It's a weird little scenario, but we've heard plenty of stories where organizations have tried, just like it says here in the final paragraph, turning off NTLM, but it causes issues with applications that use hard-coded NTLM usage, right? And this is something that developers around the world are struggling with right now as Microsoft moves toward this post-NTLM world, where Microsoft identified a certain percentage of, services that were going to be able to be easily converted over to Kerberos, a certain number of services that would be easily retooled for Kerberos. And one of the things they put out was developers, when you have the opportunity to define how users authenticate, a lot of times in the past, they've simply typed in NTLM. But if you change that, or if your application supports the ability to change that to negotiate, then it will move up to using Kerberos by default, because Kerberos is the default authentication protocol for Active Directory. All right. Whew, there's a lot there, right? There's actually a lot more there too. There's the development of a local Kerberos provider that's coming into Windows 11 down the road. I actually don't have a slide for that, but it is something that's coming as Microsoft plans this deprecation of NTLM. We do have a whole blog post that covers the entirety of what the process is going to look like. I believe it even breaks down the percentage of applications that Microsoft is responsible for retooling versus the ones that they believe are responsible out in the wild. But that's enough about that for right now, because we are moving kind of wildly into this scenario where those aren't the main things that we're talking about on a regular basis, right? So everything we've talked about so far pertains to how users log into Windows and how Windows then moves their credentials around in various ways to give you access to the things that you care about. That is all kind of the local-ish logon discussion, right? We're logging into things on the network. But the reality is most of us today are operating in a cloud-first environment. And there are a lot of organizations that are attempting right now to move from Active Directory scenarios into cloud-first environments. So most of what we've already talked about isn't really super relevant in these conversations, right? Most of it is not, we're not really looking to authenticate against a domain controller anymore. So what we need to do is start looking at how cloud services and single sign-on authentication work in the internet. And so Microsoft has done a lot of work in investing in what they call OpenID Connect. Now, OpenID Connect is an authentication protocol that is built on top of OAuth 2.0. And the reason why I'm breaking this out here like this is that OAuth 2.0 is actually not an authentication protocol. It is actually an authorization protocol. And again, just like I said at the very beginning, conditional access allows you to define authorizations as a post-authentication behavior. OAuth 2.0 does something very similar, but allows us to take identity from Microsoft and push it into other scenarios, or identity from things like Facebook or from Google or whatever, right? Essentially, we're saying I have an identity somewhere and I trust that identity, and I would like to expose a portion of that identity, 3 or 4 key attributes. They're the ones that I'm going to choose to allow, and I'm going to use that to log into some system and grant some level of read access or write access to my identity to prove that I am who I say I am to some relying party and to gain access to their systems. I do a lot of support with this, and this is where we see most preferential SSO environments happening right now. You're going to create an Entra account. You're going to use that Entra account to sign into things like LinkedIn, right? Or you're going to create a Facebook account and you don't want to deal with having to remember 50 passwords. And so you just hit sign in with Facebook, sign in with Facebook, sign in with Facebook. All over the internet, you now have one actual account and you are presenting attributes of that account to these other systems. There is also SAML. SAML is a security assertion markup language, and it works in a sort of similar-ish way, except instead of exposing attributes about the account, we're actually exposing access of the credentials. It's a little bit different. They serve similar-ish but different purposes. Microsoft recommends when you are creating content or creating applications, you use OAuth 2.0 and OID Connect where possible, fall back to SAML where necessary. So we have a lot of different ways that we can authenticate, whether it's local to the machine, onto the domain, into cloud services. But what we have also done with that is we've been constantly changing the game on our users. For 3,000 years, they have had this idea, since they could remember a password, that it's a pretty awesome idea and it's stuck in their head and no one's going to be able to guess it, and they can change it up from time to time even though they're not going to. They can recycle it, and because it's all imaginary and in their head, no one can ever get it, right? A password's going to be a super secure idea. But for the last 30-ish years, we have been telling them, no, you're doing it wrong. But every 3 to 6 months, we change what it is, right? And so it's been very confusing for users to move through this journey with us. And this is actually a pretty substantial part of what my I Heart My Password talk was based on last year. Kind of asking users over and over again to keep switching gears when all they want to do is get in and do the work that you've assigned is really disruptive. And so we have this really significant pushback on users that is not helped by the fact that through all of these changes, and all of these amazing technologies, there is still a password involved. The user still has this credential pair that they are responsible for. Even if we move into passwordless, a lot of these technologies, even their encryption ciphers, are based on a hashing and salting of the user's password to define the private key. So bear that in mind, right? This is why when we get to passkeys, this is something that users are going to be pretty excited about, and we'll touch on it a little bit. So we have our authentication protocols. We also, when we talk about authenticating directly into cloud services, we have multiple authentication methods. Okay. This went, again, this was a slide I created for that event last year. And we sort of go from left to right across here, what are not great to pretty super awesome. And very far down at the bottom, you'll see things like direct SMS authentication, which is supported, although it is going away. Direct credential pair, where a user just simply types in a username and password. Federated single factor. Right? So if you're doing something where you're presenting Active Directory in a federated environment and all they're doing is username and password, that is still considered to be a single factor authentication. It is, not the greatest from a security perspective. We can do so much more when we start leveraging and taking advantage of the cloud capabilities that are up here. So when we look near the top, and we can take these values all the way across from multi-factor through passwordless MFA and all the way up to phishing resistant MFA, then we're landing back at things like those FIDO2 security keys. Now, FIDO2, you might have seen from my list of authentication protocols, is based on public key cryptography. And that goes back to this concept of when we started looking at the major components of one, what are the players, right? If you have a client and you have a server, and now you have a third-party broker that's saying this person can be trusted, this key can be trusted, this system can be trusted, and you put them together and you allow them to work it out betwixt them, you have a much more seamless scenario, and you guarantee much higher security for all of your players. You also have a much more complicated authentication diagram, which is part of why we're not getting into that, except we kind of are going to get into that a little bit. So we're going to come back and we're going to talk about Windows authentication for just another minute or two, right? Because we put NTLM in the title of this thing, and we need to prepare for a Kerberos world. So here we go. All right. We have a scenario where Clarissa client wants to get resources from Sally server, right? So they're going to ask Deborah Campbell, who's our person in the middle. She is going to be our Active Directory domain controller. See, Deborah Campbell, domain controller, get it? So she's going to ask Deborah Campbell how to find Sally, right? Because Clarissa just knows that there's a thing she wants. I just want to go meet Sally. But she doesn't know who Sally is, right? When you walk into a room, you don't know who Sally is. You could ask, hey, who's Sally? And somebody who doesn't know any better could say, I think that person over there is Sally. So in this case, Clarissa's going to go and say, hey, Sally, I've heard that you have some resource that I would like to have access to. It sure would be swell if you would give me that access. And so she's going to hand her keys to Sally, who's going to go run off and find Deborah and do the authentication. Okay, so Clarissa is only talking to Sally, and Sally is going and finding Deborah in the background, except it may turn out that Sally is actually not Sally, right? We actually don't have a way with NTLM, as I mentioned earlier, to authenticate that the service or server that we're talking to is really the one we expect it to be. This is something that I have blogged about a lot in the past when Microsoft first announced that they were going to move to deprecate NTLM. And in fact, it's in that blog that's referenced at the top of this recording. So when you're looking at it later, I'll make sure that this goes into the YouTube description. We as admins in 2003 started seeing client errors whenever we would spoof a server's name on the network. And there are a lot of good reasons why you might want to spoof a server's name on the network, right? Let's say you have print server, right? Or file server, and you may have 5 or 6 machines that might be rotated in to host that role. We're not going to worry about them being a clustered server. It's just file server is the friendly name on the network. Users are connecting to it and they're expecting to be able to get resources from file server. That server may actually be something called XKBG10429, it doesn't really matter. The client is looking for file server. DNS is saying, I have an alias for that goes to this IP address. Go forth, right? Or Maybe the client is just requesting by IP address and it doesn't even know the name. NTLM is super duper cool with that. But if it gets a name that it's not expecting, then it'll throw a warning, not an error, a warning, saying that the server name is a mismatch from what the client is expecting to see. But admins, we've known that for 20 years, we could disable that or kill that message by simply enabling a registry key called disable strict name checking. And I've seen this in place in a lot of organizations. In fact, I've put it in place in a lot of organizations because it was very convenient 20 years ago to simply rotate a friendly name. Now, documentation on exactly how to do that is still published, although it does say this should not be done for future scenarios. And if you go and ask Microsoft engineers, they will tell you, yeah, that's a terrible idea, because in those scenarios, what they view as happening is the server is lying to you. And that makes that this use case susceptible to attacker in the middle, where essentially now, instead of even you talking to Sally, now I can put a box between you and Sally, and it can replay your conversation to Sally and replay the credential readback and all that kind of fun stuff anywhere else on the network it wants to. It'll act like a blind proxy server, and your client will never know, right? NTLM is designed to be reliable even when it doesn't have line of sight to a domain controller. So as long as the service itself has line of sight, NTLM client says, cool, as long as you know how to find that domain controller and verify my credentials, we're good, right? That's not really what we want. That is susceptible to some pretty nasty attacks. Kerberos, by default, though, doesn't do that. So you'll notice in this scenario, all of the conversation between the client and something else is happening between it and the broker. In this case, the broker is a key distribution center. It's a ticketing system. It's Active Directory. The server itself is really only verifying that the ticket granted to the client matches access to something and that the session is valid for its time, right? So we get time stamping, we get mutual authentication, we get proof that Sally is indeed actually Sally. We can't spoof that. And if we want to spoof it, if we are so desperate to spoof that name that we really need to be able to recycle that, there's actually a method to do that, but we have to publish that as an SPN into Active Directory to tell it that client requests forevermore going to Sally should be redirected to this object. But it's an intentional choice. And yes, we can actually do this for IP addresses too, but that's way out of scope for what we're looking to talk about today. What we need to understand is that the client conversation is happening with the KDC, key distribution server, okay? In most cases, this is going to be an Active Directory. The challenge that we get into with cloud scenarios is that we don't have line of sight to a domain controller. And the way that Microsoft is solving this in the future is they are introducing an iteration of Kerberos protocol to run locally on Windows 11 machines called IA-Kerb. Don't remember what it stands for. It doesn't really matter right now. It is a local implementation of Kerberos to allow us to move past this problem of needing direct line of sight to a domain controller at all times. It is still Kerberos, but our tickets are going to be produced and authenticated locally based on real actual credentials that are stored on the machine. Okay, so that's a lot to cover around NTLM versus Kerberos. NTLM is going away. It will be de-supported in a future version of Windows. Right now, we still do not have a timeline on that. We do know that Kerberos is going to be the method that's going to be supported. We know that they're going to get a local Kerberos for clients to be able to operate in disconnected environments. So with all that said, let's go back to talking about the different authentication methods that are supported in Windows in the cloud. So I did mention this, and we talked about kind of how we move from right or from left to right and improvements. And we go back to that concept that we've been saying for years, that 99.9% of attacks can be blocked with multi-factor authentication. But if we compare that to the Microsoft Digital Defense Report that has been published for the last several years and the adoption of strong authentication over time, and I will caveat, this is last year's data, not this year's data, we are still really struggling to get both users and administrators to adopt strong authentication. And so some changes have been happening in the Microsoft cloud that have really kind of helped push the needle forward, lift the bar, however you want to express it, where these numbers are now actually about 10 to 15% higher. We're seeing 40-ish and starting to crest into the 50-ish percentile. Microsoft has stated as a public goal that they want all authentications to happen in MFA scenarios. Now, in order to get to that point, we actually need to go back to looking at our authentication methods, right? And now putting them into the context that they exist in the Entra ID space. So our authentication methods in Entra, we actually have a fair number of them. And this slide is a little bit old. You'll see that it still says Azure AD Security on it, and FIDO2 security keys are kind of now how we would refer to passkeys, although that can also include physical hardware keys. We have a lot of different ways. We can target these to different users, to different groups, and we can actually do things like revoking specific GUIDs and all this different information that we can define very granularly how we want to control who's able to authenticate to what. But really importantly, and this is one of my favorite things to present to customers when I'm talking about security kind of all up when we do immersion experiences, is that we don't really have to babysit this anymore. So last year, this was published June 1st of last year, so it's a year and 27 days old right now. Microsoft gave us the ability to just turn on system preferred MFA. So I mentioned for 30 years, we've been telling users you're doing it wrong, and we keep changing the way that they do it. But every time we change the way they do it, we have to go and find out what is the new hot button method of the week, right? That's always been on us to go figure out. But if we're leveraging cloud technologies anyway, and we're taking the shared responsibility model of saying Microsoft knows how to host a server, not my problem. Microsoft knows how to host a network stack, not my problem. Maybe Microsoft also knows how to best manage the current latest and greatest MFA methodology. Maybe that doesn't need to be something that I worry about all night. Maybe that doesn't need to be something that I babysit or stay on top of, right? I'm trying to take advantage of the shared responsibility model. Let them be responsible for this too. Anything that I can take off my plate allows me to focus more heavily on what is it that my company needs me to deliver and how do I deliver it. So again, system preferred multi-factor authentication is a super duper option. It's on, off, or Microsoft manage, or basically, and this is now the default, I believe. We want to target this to all users and just let it go, right? For the most part, this is going to be a pretty good thing. And we'll be able to actually track how people are authenticating. This is another one that I see pretty regularly. Organizations don't know exists, right? I've turned on all these things, and I know there are some users who are resistant or struggling, but how is it actually being used in my environment today? Well, you can actually track that. There's a field, there's a screen right here that shows exactly what methods are being used, how users are registered, and if you're running into a scenario where it's not happening, right, users capable of passwordless authentication looks really, really low and 95% of my organization isn't capable, I can click on that and it'll tell me exactly why. Every single user will be listed as to whether they have registered a phone number or MFA methods or what, and we'll get an explanation of why they are not using MFA. It's super duper simple. It's right here under monitoring and activity under authentication methods in Entra ID. The other thing that happened, though, last year was that Microsoft made the mobile app a free second factor for all enterprise customers. And this is kind of well, it's not kind of a big deal, it's a huge deal, right? We used to have this challenge where in order for you to get MFA for your users to even start thinking about that 99%, you needed to go to Entra ID Premium or Basic, right? You're either going to have to leverage this through some sort of like a paid step-up SKU or something. Well, now if they're using the Authenticator app, which by the way counts as a passkey, we'll talk about that in just a moment, they are able to use that as a multi-factor authenticator. With biometrics, with anything you want to layer into it, they can absolutely do it. So we have all of these different things that are here. And again, and now we can actually also layer in risk-based authentication conditional as part of our risk-based controls as part of our conditional access too. So a lot of stuff that we can do here. But passwordless is free. Phishing resistant passwordless authentication, FIDO2 compliant, phishing resistant passwordless authentication is free for all of our users. It's no longer locked to global admins. We can do it for everyone. So I've mentioned passkeys a few times. And this is something that has been kind of growing in momentum. I really wrestled with how much explanation passkeys really require at the moment, because you're using them pretty much everywhere nowadays. It's been explosive over the last year and a half. But if you remember way back on my list of authentication protocols, in order to leverage passkeys, we have to be at FIDO or later. FIDO and FIDO2 are later. And what they're going to allow us to do is to create a unique cryptographic key pair that's going to be based on public key cryptography. And the really cool thing with Entra is that you don't even have to necessarily bring your own keys, because by registering your Entra ID domains, you get the keys for that. So it's super cool. You don't have to build CAs or anything like that anymore. It's a unique cryptographic key pair used for secure communication, and each site or service requires its own separate passkey. Now, we've spent a lot of time over the last several years talking about the importance of things like password vaults and password managers and all that kind of stuff, because users love to recycle passwords. And again, for 30 years, we've been telling them not to recycle their passwords, creating all these crazy rules, setting all these different expiration policies. And so what do? They come up with password 1, password 2, password 3, right? And they're going to recycle them all over the place. Well, passkeys get away from that, because what they're doing is they're basically saying, you've signed in once with a password. Now we're going to build a passkey around that. We're going to store that passkey either in your computer or in your phone. You're going to unlock access to that passkey with a biometric. If it's on the computer, you're going to use Windows Hello for Business to do that. And the really cool thing about Windows Hello for Business, if you're using a computer that has a TPM, which Windows 11 basically stipulates that you're going to have to be coming from a TPM-enabled device anyway, and you have virtualization enabled on that machine, Windows Hello for Business takes your credentials that you are entering into Windows, and instead of just storing them in a password manager in Windows like we used to have, replayable through things like Mimikatz, bad thing, it's going to encrypt those credentials and store them in a virtual machine or virtualized spot on the machine. So you cannot simply come back and replay credentials, right? They are not available to Windows until they have been unlocked through Windows Hello for Business to then be replayed back into these sites that are specifically enabled for passkeys. Google rolled out passkeys earlier this year. Apple's rolled out passkeys. Microsoft is bringing in passkeys to everything. And yes, you can actually also do them with your phone. And when I say biometrics with your phone, you're going to be able to do whatever the biometrics are that are supported on there. Interestingly, for those who have been playing the biometrics game for several years, you may have heard me say in the past that iris support is not real. And it turns out that I have to eat a tiny bit of crow on that, because iris support is very real, but only on Microsoft HoloLens 2 devices. So we do have some very limited support for iris, but we can do fingerprint, we can do face, we can do PIN, which obviously your PIN is something that you do have to know, but it isn't traveling to the next device, right? It's locked to the device. So the private key is stored securely on the user's device and is never shared with the server. And passkeys are used to authenticate users and services, proving identity and securing further communication. So passkeys move us past the world where we have to worry that users are just retyping passwords all over the place. They're using my corporate email address with the same daggone password to authenticate to 50 different things. No, they're not. They've created some credential pair. That credential pair is encrypted. It's managed here. The user is simply replaying that with a passkey into that service or application, and they're then able to gain access to that. Passkeys are revocable, so you can delete them, you can move on from them, right? They're disposable. They actually are a little bit like a software implementation of a YubiKey, which if you've never seen a YubiKey, it's a physical plug-in device you stick into the machine, you provide some sort of a physical gesture. Passkeys are that, but virtualized into a software token. So super duper cool stuff. NTLM is on the way out. Kerberos is going to be coming in with its local implementation of Kerberos. There are a million different authentication protocols. There are tons of different authentication methods that are supported. And then each one of these is going to have an implication on how many constituent components are involved in that authentication process. And that is before we ever get to the point of deciding authorization. So, with that, I want to thank you for joining. I will apologize. My Q&A function is not working. I did try to get that resolved before we went live today, and I was unable to. So if you have questions, they are captured. I just can't see them, and I am so sorry. We will get you answers to your questions that you may have asked. But thank you for joining. I hope you enjoyed this, and I hope you have a great rest of your day.